Good morning. In today's chapter of atomic structure, we'll be discussing the different types of atoms and the elements which make them up. So, firstly, we'll be talking about the atomic structure. The atomic structure consists of protons, neutrons, and electrons. Now, the important thing is that to know that the electrons have extremely negligible mass, so the major amount of mass is made up by the protons and the neutrons. And similarly, the mass of protons and neutrons combines to make the nucleon number. Now, we'll be talking about the properties of proton, neutron, and electron respectively. The electrons are negatively charged and protons are positively charged. Overall, the atom is neutral. So, in order to for the atom to become neutral, there are always the same number of protons as well as the electrons. Now, the proton number is the number of protons, and the nucleon number or mass number is the number of protons combined with neutrons. So, what is asked in the exam? In the examinations, it is asked, for example, you will be asked to find out the number of electrons in a specific atom. You have to know, and you will be, for example, given the nucleon number. So, you have to remember that the number which is written above is of obviously greater. So, this makes up the number of protons and neutrons 24, and this is always the number of protons which is written over here, and this is also known as the atomic number. So you just minus 24 with 12 and you get that there will be 12 protons and 12 neutrons. However, as we know that the number of positive and number of negative atoms must always be the same, so the number of protons will be equal to the number of electrons, so you get the answer 12. Now, I talked in the last video about the electronic configuration, that there are always two in the first shell, second in eight in the second shell, and third in the last shell as well, for it to become stable. Although it's written that the third shell can hold 18 electron, but for stability, in most types of electron shells, there are only 8 electrons. Now, when we come to an ion, what is an ion? Ion is anything when it can be positive or negatively charged when an atom loses or gains electrons. We talked extensively about the subject in the chapter of chemical bonding. Now, what are isotopes? Isotopes are basically atoms which have the same number of protons, but if atoms of the same element, rather, I would rather say, which have the same number of protons but different number of neutrons. This definition is repeatedly asked, and the common examples are given over here. For example, chlorine 35 and 37, and another example is uranium. However, uranium is an unstable isotope, and why is it unstable? Because it has an extremely high number of neutrons. Now, you were repeatedly asked in the exam to calculate the relative atomic mass two elements, and we're giving the relative abundance of them. For example, in this question of chlorine 35 and 37, we're given that you can basically just understand this concept. For example, that we'll give taking the average of two elements of the relative abundance of two elements. They've said that we have 75% chlorine 35 and 25% of chlorine 37. So we just calculate 75% of chlorine 35 and 25% of chlorine 37, and then we add up the two, and this gives us the answer of 35.5 relative atomic mass units. Now, I before we talk about the periodic table in detail, I would like to show you a picture of the periodic table. Here we can see that the first two groups are over here. These are the metals. The lid for this is group one, this is group two. Now, this entire group comprises the transition elements, and after this this is group 3, group 4. So primarily, since we the first three groups, group 1, 2, and this group 3, these are classified as metals. Group 4 principally consists of basically alloys, including carbon, silicon. They all have giant molecular structures. And from group 5, 6, and 7, these three groups mainly comprise the non-metal atoms. And group 8, they all have 8 electrons in their outer shell, and they are noble gases, and they are inert. So in after talking about this, you need to know that we'll be talking about the specific properties of group 1 and group 7 in detail, because of their properties and usefulness in our daily lives. So I talked about why metals are solid and malleable and ductile in the previous video, and why non-metals are poor conductors of electricity. So their physical properties are often asked that metals are shiny, whereas non-metals are dull, obviously. Now, that if we talk about the differences of metals, what are reducing agents? And reducing agents are anything which oxidize agents, which basically reduce others. How do they reduce others? They reduce others by oxidizing themselves. And what is oxidizing me? We'll talk about it in detail in the chapter of redox reactions. However, just to give you a pretty basic concept, I'll tell you that atoms get oxidized or ions get oxidized by losing electrons. So basically when a metal loses electrons, it obviously gives it to someone. So the substance which loses electrons is always oxidized, and with the substance which gains electrons, in this case it's always metals are basically oxidizing agents, or they get reduced themselves. So metals, we all know, are involved in ionic bonding, and non-metals in basically covalent bonding. Now, you need to know the specific properties of the element of the alkali metals. Alkali metals are also known as group 1 elements. This is the group 1. So, first of all, we need to know that they are involved in ionic bonding. So, in ionic bonding, they all obviously conduct electricity. Apart from there, the physical properties are that when combined with oxygen, they always give a lithium oxide. When combined with water, they give a solution of a hydroxide. And we need to know that group 1 basically elements are extremely reactive, and when we react them with water, hydrogen gas is released. So hydrogen gas is always a byproduct when we react them with water. What are halogens? Halogens are those elements which are present in group 7. These are elements: fluorine, bromine, iodine. So when basically group 1 elements react with group 7 elements, they react to form a metal halide, and halide is basically this complex. Now, if we come into the individual properties of group 7 elements, we need to know that they're in their elemental form or atomic form, in which they combine and they are stable. They're always present in the form of diatoms. Diatoms mean that there are always two atoms present. So you will always see hydrogen, chlorine, fluorine written as Cl2, F2, Br2. This is a thing to remember for them. Now we all know that they combine with metals to form ionic bonding. And if you've seen my video on bonding, you'll know that how to basically cross over their valencies and get this FeCl3 formula. Now, the most important reaction which has been repeatedly asked and repeatedly tested is the displacement reaction. For it, you need to know that the basically we need to know the trends in group 1, group 7, and transition elements. The trend is that the reactivity decreases as we go down the group. You see, fluorine is mainly a gas. The more reactive a substance is, it basically exists in the form of a gas. So fluorine, chlorine, bromine, iodine. As we go down the group, the reactivity of basically elements decreases. So now, as we go down the group, what is a displacement reaction? Displacement reaction is that as we know that chlorine is more reactive than bromine, as you can see here, because it is basically higher in the periodic table. So as chlorine is higher in the periodic table over here, you can see that chlorine is above bromine. So it basically displaces bromine from this basically reaction with the potassium, and it gets inserted, and this forms potassium chloride, and bromine is instead released. So in this reaction, they'll be giving you hints that there is a reddish brown color released. What is the reaction? We need to know that the reddish brown color is always of bromine. Similarly, some other trends are that as we go down the group, the color of the compounds becomes darker and darker. As we saw that bromine lies beneath chlorine, so obviously bromine has a darker color than chlorine. And just for your understanding, the basic colors are that chlorine is colorless, and bromine has mainly a brownish color, whereas iodine is purplish in color. Now we come to the transition elements. The transition elements, as I showed you above, there examples of them include iron. and it is the most important transition elements. Their physical properties are that they are extremely hard and have high melting and boiling points, and they are malleable in nature. They have catalytic and activity. We talked about it in the chapter of catalyst. What catalysts are, so I'll not be repeating it in detail. Now, the most important thing is that they basically exist in different oxidation states. This means that, as I showed you, that iron does not lie in either one or two or three. You don't classify it in a specific group. So it does not have a fixed amount of electrons in its outer shell. So the types of valencies you'll be seeing it in are mainly like Fe+2 or Fe+3. So it can lose either two electrons or three electrons. This is a distinguishing factor which distinguishes it from all types of other things. Now, transition elements are also good conductors of heat and electricity because they have freely mobile or moving electrons. The word freely moving or mobile or delocalized essentially represents the same thing. And finally, we'll be talking about the last thing before we go off is noble gases. Noble gases, as I showed you the picture, are eight electrons in their outer shell. So they are always inert. Now, yeah, now for helium, we need to know that like hydrogen had after bonding, it had two electrons. Helium has two electrons in its outer shell. So now we'll be talking about the uses of noble gases. Noble gases such as neon you would have seen that they are used in advertising and the laser beams and to make fluorescent things. Similarly, argon is used in light bulbs, and apart from that, radon is a radioactive gas. So you just need to know the thing important is that noble gases are all inert in nature. We'll be doing the applications of all of these and the questions which arise from them in the next video when we do the past paper practice. For now, this similarly wraps up our video on atomic structure. Thank you for listening to the video.